Okay. Uh, as I mentioned, uh, we will start with Unit 1, that is curved beam. The reason why I am taking curved beam is again in Unit 1 there are two bits. One is a spring. Again in the spring, to be specific, we have helical coil spring and leaf spring and the curved beam. Okay, so since the curved beam is a small bit, since I am also, in fact, I have taken online classes. Most of your seniors might have already conveyed or communicated to you. So, but however, since it is a it was a learning phase then, but now we need to be much specific and then see to it that all of you will be comfortable. So I also need your feedback, whether you are comfortable or any improvement you would like to have and all. So in that context, I have taken a small bit of this particular syllabus so that any lacuna is there that can be rectified later, and then ultimately you will feel yourself comfortable. Okay, so this time it is unit wise. Okay, unit 1, unit 2, unit 3, something like that. So in the first unit you have again, as I mentioned, you have a helical coil spring, a leaf spring, and then curved beam I will be taking first. Okay, so let us see quickly what all we have in the next bit. Okay, I'll give the quick glance about a curved beam. Uh, we will see what all we are going to cover in this particular curved beam section. So this basically happens to be in unit 1. So as I mentioned earlier, since this particular section or topic is of only 2 units, okay, in that context I have chosen this as a first this thing. So there are a couple of reasons why I have chosen. One is basically, since the time is less, if any lacuna from my side, either in communicating or making you being a comfortable this thing position, so I would like to know the feedback. So if in case any lacuna is there, so that can be rectified in later chapters. Okay, in that context I have chosen this. Other than that, nothing. Okay, so this Excel sheet I have made, one is first column, this is a unit which I have written unit 1. So this time it is unit wise your syllabus, it is not chapter wise, it is unit 1, unit 2, like that. So each unit you will have some 2 questions. Out of that you are supposed to answer any one. Okay, that is question paper scheme, so that we will see later. So this happens to be in unit 1. And prerequisite I have mentioned in the second column. What is that prerequisite means? Before going through this particular curved beam section, you are supposed to know some of the fundamental. So that is just like a brushing up. Okay, either machine design 1 or strength of materials. I will just quickly glance through. Prerequisite for this curved beam is a knowledge of bending moment and tensile stresses, shear stresses, compressive stresses, and combined stresses. What does that mean? You are supposed to know what is meant by bending moment, what is meant by tensile stresses, and what is meant by shear stresses, compressive stresses, and combined bending stress. Okay, so we will quickly cover up as and when we cover up that bending equation. So just quickly glance through yourself. Then again, you should also be aware of stress distribution in a straight beam. Okay, straight beam means it is a curved beam only, but while deriving the Euler's equation we consider it as a straight beam first and then apply the bending moment. In that context we consider it as a straight beam only. Okay, and different loading conditions like tensile, compressive, that is, you should also know how that loading is being done on that straight beam. That is basically Euler's equation you are supposed to know. What is that Euler's equation? M by I equal to sigma by y equal to E by R. Okay, this is the bending equation, classical equation, what you have studied in your strength of materials. Okay, so that you should be aware of. Again, whatever we are going to cover, it is based upon that. So as and when we cover, as I mentioned, we will look into that, what is we have learned and how far it is going to be different in this curved beam section. Then again, what is the learning object? The third column, learning object means why you are supposed to learn this. Okay, so the objectives of learning this is students should able to distinguish between straight beam and curved beam bending equations. That is, whatever you have learnt, that straight beam Euler's equation, how far it is different from what we are going to study in curved beam and why it is important. So that we are going to see through after going through this chapter. And you are supposed to know the difference between geometrical axis and neutral axis. I am going to tell this what is meant by geometrical axis, what is meant by neutral axis. After this thing, you are supposed to know differentiate between, and also you should be able to apply the equations for practical problems like machine problems like machine frames, crane hooks, C-clamp, so and so forth. So you should able to apply the knowledge to solve the problems pertaining to this. So that is the objective of this particular learning. And what all the content of the chapter? Content of the chapter is, as in the syllabus, comparison between straight and curved beam, problems in crane hook and C-clamp, expression for stresses. So that is what is all about the chapter content of your syllabus. Okay, then one is objective, so another one is course outcome. Okay, so outcome means after learning what is that this thing. Okay, so students will able to differentiate between straight beam and curved beam. This was objective, so after going through the syllabus you will be knowing that. Okay, and then you will be able to understand the importance of geometrical axis, neutral axis. Here the same thing is being told. So this is objective, this is outcome, that's all, nothing more than that. Almost here you are supposed to, here you will be, something like that. Okay, and you will find the stresses in curved beam and applications of curved beam. Okay, then teaching method, in fact what I am that adopting, in fact since it is a COVID crisis still, so there is no question of chalk and talk. It is, or everything is on PPT basis only. So PPT to show straight beam and curved beam. So some video I will be showing and make you comfortable, and their applications, nomenclatures of curved beam and straight beam, and audio video lectures as usual. Then again, what are the type of problems we are coming across in this particular chapter? The type of problems are curved beam. So we will be solving around 2 problems on curved beam to be specific, and a C frame of different cross section, again 2 more problems, and then a crane hook of different cross section. We will be looking into 2 more. Again, how to solve that and all, how to this one solve, and then going through the problem. It is a bit hilarious task. I'll try my level best so that you will be comfortable, and of course your feedback is also very much essential, as I mentioned. So in that context only I have taken this curved beam first. Okay, then also you are supposed to go through some of the tutorials, which I am very much particular, and it's a mandatory, to be frank. Okay, so students should submit the following after the end of chapter. What all? So derivations of Euler's equation, that is a curved beam equation, Euler's equation, whatever you have studied in strength of materials, again you should submit that, and identify curved beam application in day-to-day life other than machine frame, C-clamp, crane hook. Number of hours, it is 2 hours it is mentioned. Actual hours of syllabus coverage, it is not possible to cover in 2 hours. Minimum 4 hours is required. And textbook, in fact I have mentioned Robert Norton, which is a very good book. So they are available in our college library, do get them. In addition to that, Bandari is there, and Joseph Edward Shigley. So these 2 second and third are going to be your reference books. Of course you can rely 100% on my syllabus, whatever I am covering only. Okay, done.
Consider a prismatic beam. When equal and opposite moments m and m' are applied, as shown, the ends of the beam bend upwards. Fibers at a certain position, called the neutral axis, do not change in length, while fibers above it shorten and fibers below it elongate. For linearly elastic beams, this neutral axis passes through the centroid of the cross-section. and when the beam is bent, forms an arc of radius rho. We describe the position of a fiber by its distance y from the neutral axis. The amount of stretching or shortening in a fiber depends on its y value. Y coordinates above the neutral axis are positive and below it negative. Consider a segment of beam that is ds long. As the beam is bent to a radius rho, a fiber that is a distance y above the neutral axis has a new length ds star and a radius of curvature rho minus y. Two similar isosceles triangles result, and we can write rho over ds equals rho minus y over ds star. Rearranging gives ds star equals rho minus y over rho times ds. The strain epsilon is equal to the change in fiber length, or the new length minus the original length, divided by the original length. Thus we have epsilon equals ds star minus ds over ds. We can substitute ds star from the previous equation. Divide through by ds, simplify, expand the first term on the right side into two fractions, simplify again, cancel the two ones with each other, and we are left with epsilon equals minus y over rho. This linear relationship between epsilon and y can be illustrated graphically. Before the beam is bent, rho is infinite, and the strain is zero everywhere across the depth of the beam. As the beam is bent, rho decreases, and the strain in each fiber increases. In all cases, the strain varies linearly with y. Fibers above the neutral axis are shortened and experience a negative strain, while those below are elongated and experience a positive strain.
Okay, that was the video. In fact, that is also copyright. It's not mine, but however, they have mentioned for education purpose, there is no problem of using that video. In that context, I have inserted that. Please, if you have carefully observed, what he has mentioned there is, it is basically straight beam. Okay, basically it is a straight beam. Straight beam means what? It is a straight with axis, okay, in between that particular cross section or in between the particular height of this. Okay, so this is the geometrical axis. Okay, geometrical, okay, axis. So this geometrical axis we call, or sometimes we also called as centroidal axis. Okay, centroidal, both are one and the same. So what is that? Basically, geometrical axis or centroidal axis, it is an imaginary axis which passes through center of gravity, CG. If you consider this particular bread, okay, bread, I think this bakery bread, you know, that they make a slice and then give it, no? So if you pass a rod at the middle of that particular individual bread pieces, so that you can call it as axis. Okay, similar to that. Okay, it passes through the CG of that basically. Okay, so this is a straight beam. So that straight beam is basically, okay, so bent after this thing. This bending moments are being applied on the either side of that. So that will be bent in this particular section. And if you have heard or watched that video very carefully, what he says is, this neutral axis, whatever that layer is there, that will not be deformed, that is it is in a state of undeformed condition, and fibers on the top side, okay, so they will get compressed, and then fibers on the, that is on the top side, fibers will get compressed. This is the top side, and then the bottom side they will get expanded, okay, they will get expanded. So expand means what? It is going to be some sort of tensile stress in the bottom, and then some sort of compressive stress in the top, okay. And one more thing he has told is that of course it is a strain, this thing displacement, he in the final last slide he shows that is linear, actually, that strain, this thing is linear, okay. Linear means what? It varies uniformly with respect to the central axis. So this central axis, generally if this is a stress pattern, okay, if this is a stress pattern, so what we just mentioned, so that geometrical axis, okay, that geometrical axis geometrical axis will be coinciding with something called as a neutral axis. So this we have all learnt, neutral axis, okay. Both geometrical axis and neutral axis coincide when coincide. So when you consider it as a straight beam, both the geometrical axis and neutral axis, they coincide, and the stress pattern is linear, in case of straight beam. That is what is the narration, so which is not true in case of a curved beam. Why it is not true? Because the curved beam, initially it will not be straight as it is over here, it will be curved only. Because of that, the stress pattern will not be linear, it will be curvilinear, okay, which I will be showing it in a next slide, okay.